Hey everyone, and welcome to the PGXUI YouTube channel. I'm Edward. In this first video of the channel, we're going to be taking a look on OTP, some best practices around GenServers. We're going to play with DynamicSupervisor and the Registry. Hope you like it, and let's get to the video after the intro.
So, the idea of the project that we're going to start is a caching mechanism for the classes of students. Like me, they could be in class A or class B inside a school or something like that. So that's how we are going to be using this concept so that we can explain the ideas around GenServers, registry, and generic and supervisors and dynamic supervisors. So for beginning, we're going to do this. We're going to start a new sample app. And we're going to fetch all the dependencies. Cool. There we have our application. So let's enter in this sample app. Let's git init, git add all, commit this commit. Okay, so again, like this idea here is for us to be able to create like as many caches, and these caches are going to behave as like the database for all the students in a specific class. We're not going to be really reaching out for external services, but we can like kind of like abstract the idea inside like a module for our service. But like, let's just stop chit chat and focus on the code. So the first thing that I do normally is create a services module. And then here we're gonna create here like the students. Actually, this is a module also called student service. Okay. There we go. And here we're gonna have like a cache, right? Because that's how we said we're going to be creating. So if I do def module and if the Elixir language server works, yep, it did work. So there we go. We have like a cache, and we are going to be using a GenServer. For this, I'm going to start the application. And actually, I forgot one thing. My editor always complains if I don't add credo. So I have the credo line here. And I'm going to actually come here, mix deps.get, and now I'm going to start the application. And there we go. We have an application here. And whenever I start a new GenServer, I normally go to the documentation. So help GenServer. And there is a stack documentation of GenServer somewhere around here. Okay, so I'm going to get this guy here. And we are gonna paste inside our cache. So here and paste. There we go. We have our GenServer, and we don't care about the push and the pop because we're not implementing a stack. And again, we don't need the handle calls for that. And here it's gonna be like the public API. And I always like to do something like this so that it's like more beautifully aligned. And like this, and I think maybe this, and this. And this is gonna be the callbacks. And I also like to create here private functions. So just so that we have like some sort of functions. And here. There we go. And since we are like always writing tests, let's create a unit test for this guy here so that we start in a good shape. And we're gonna use the sample app dot data case. And here, let's just create a describe block. I don't care that much. And here's be a test. And here, do end, assert true. I'm not 100% sure if we, oops, we gotta do a mix deps.get, deps, not get. Okay. Okay, we have like our application able to run tests, and what we want to test is the start link function. And that start link function has like array of 1, and we want to say that success can start the GenServer. Actually, let's say start the cache. And for this, we just need to run the cache. called start link, and with like just pass an argument and already, and here should return for us, okay, and a Pete, and I think we're good for now. Amazing, we have a successful running GenServer application. Okay, let's go for the good practice. So we said before that this is going to behave like as a database for a student's class database for pretty much, so records. So the first thing normally I do, I define a struct, def struct for the GenServer. We're probably gonna have like a bunch of students, which by default it's an empty array, and like some sort of student class name, which will be like an empty string by default. We also need to define a type T for this GenServer, which will be like this module, like this, and we're gonna have like students, right? And this is gonna be a list, and we're gonna have like the student class name. It's gonna be a binary. Cool. With this, we can like already start playing around with the idea of CRC from brew state, where we can start create here the def new, which is the create, and this here we'll do the underscore struct with this guy here, and we can do the same thing but with arguments, args and args. With this, we can, instead of returning like anything inside our stack, we can start returning something of our state, which is pretty gonna be the new function. And so that we can test and ensure that our function, our GenServer really like has the state that we just designed, we're gonna create another function here called getState, which receives a PID, do end, and then we're gonna call GenServer.call, like passing that PID and the getState function. After this, we know that we need some sort of handler, and let's create the handler here in the callbacks area for handle call. And here we said that we're gonna be handling the get state. We don't care who sent it, and we have some state here that we wanna return back. So here and here, and we can pretty much even assure that this is gonna pattern match, like not necessary, but like just for the sake of completeness, do this, and we can now assert that the cache dot get state passing the PID is gonna be, it's gonna be something as we just established, but just let's run the test and probably this will tell us what it is, and that's what we were expecting. And this, so this, and we don't care about everything up to here. Cool. We have the student class name, and we can pretty much, we probably want to start like, so each GenServer is going to represent again this database, and it's going to be per class, per student class name. So we should probably pass this thing here in the start link for, let's say, class A, right? So now I have like that thing here in the arguments. So the start link actually receives arguments. Where is it? Word args, let's like spec here. So let's say that start link return receives a key word and returns the GenServer whips GenServer dot on start. Okay, so there we go. And now that we have like some args here, we can pass these args here. And if you run our application once again, the student class name should be class A, and it is. Okay, so now we have a class, we have like a cache for class A. What wanna do next? Let's start spawning this GenServer on demand. Okay, so let's create here like the cache. Actually, let's go cache spawner ex, and this here with this, and we're pretty much going to create a function called spawn child to end, and here we need to receive like some arguments, and that's where we're just gonna need to start our dynamic supervisor. So for this, we can actually call here dynamic supervisor, and it's gonna be like spawn child. This will be the name of our dynamic supervisor that we need to start the application.ex. So here we're gonna see student class spawner. I think that's a good name. And here we need to pass the name of our cache. We need to pass here our cache and the args. And let's create a unit test for this guy here. So here, use sample app, data case. I really hate to write this first part, so I'm just gonna grab this. Actually, grab this guy here as well. So cache, because we probably need this guy here. Okay. And this gonna be spawn child. Can spawn child, can spawn student class cache, and this should be the spawner. So let's do like this. It's okay, spawner, and if we do this, but spawn child with the same arguments, we should receive that PID, which is from the end. Yeah, I think this should work. Yeah, of course I didn't. Okay, so as I mentioned, we need to choose student class spawner. So this should be our dynamic supervisor. We need to start this thing in application.ex. So after here, let's create a comma and let's create here our dynamic supervisor. So for this, dynamic supervisor, and we need to pass here a bunch of props, and pretty much the one that I care is the name and this strategy. It should be 1 for 1. It's always good practice whenever you are playing with dynamic supervisor that you create a registry. So registry, and I don't care about this guy here. Name, and this should be the name of a registry. Let's put student class registry. There's a comma here. And just for the sake of, I'm gonna close this guy here. Where is it? Dot. I close stuff here, sorry. So if we do, actually we need to restart the application because we just changed the application.ex, right? So actually, cd Phoenix UI simple app. Yeah, that's the one. So application for our, we need to pass here case unique. There we go. So now that we just gotta be sure that these guys are active. So if I do process dot where is this guy here, it says it's there. So we know that the registry started. And if we do the same thing, but for our dynamic supervisor, we know that it is there as well. So now we can go back to our student service and the spawner. And now let's provide a spawn child to dynamic supervisor. Let me see what's the issue here. Actually, it's not spawn child, it's start child. Let's start child. So this, let's see if it, yep, it works. I don't know why. Yep, okay. Everything's working once again. So now we know we have this thing working, but we have a problem. So now that we can spawn childs on demand, like as we just did, and we just check like how we can retrieve, like, hey, let's say we did this thing like for a long time ago and I want to retrieve this speed. Like, there's no reason because this thing was never registered anywhere, and this is where the registry comes into place. So the next thing that we are going to be doing is actually naming our GenServer. And for this, it's quite common that we use like the notion of a via tuple. And we are going to use the student class name as our ID. So here we're just going to have like an array here, and we're going to have the class name, and again this, and now we're going to pass the student class name here, and we're going to create here at the bottom a via student class name function, and for this we're going to have like a via tuple. We're going to pass the registry, and we're going to pass the name of our registry, which that I totally forgot, which is application student class registry. So come back here and back here, and the name of our student, our ID. Okay, so if we do this, actually one thing that we can actually do as well is inside pass the ID here as our. I don't care. I don't care actually. I don't want to do it. All right. Okay, so with this, we can be sure that our GenServer is registering our cache. And if we test here, so if you do a test, fail should not be able to create two caches for the same student class. This should be valid, so if we do this twice, the second one should fail, saying that it's already started. And yep, we got it. So we just did our sanity check, and we can actually say that this speed here is the same as the speed up there. Cool. Okay, now we can start process on demand, but we cannot still query like that process. So let's create our student registry helper.ex. For this, we are going to use the registry module, and let's create a function called list all caches. Okay, do end. For this, we can come here, do help registry.select, and we can see that with this we can grab all the process for a specific registry, and ours is called student class registry. And if we come back here and do this, and we come here to recompile, and we call this guy here, and this dot list all caches. We have none because we just started this application, so we can actually need to I'm just gonna do a doc here because I don't want to do this thing in the future, list caches again. So yeah, there we go, and this should be an example call. Okay, so if I do the spawner, do like this, doc, okay, example call, like this, dot spawn child, and for this I need the cache student class, and here class A. So if I do this once again, do this, and now I do this, there we go, we have class A, but we just have the ID, which is totally useless. I need the PID, and the PID is the second argument here, 2, and I want to get rid of this, and this should be this should be ID here, this should be PID, and this should be this. Actually, it's this guy here. Compile, and if I do this, okay, there we go. We have like our ID and our PID, and things are getting good. What we can actually do as well is list caches by which is the thing that we call it, cache by student class name, by student class name, and here we have the student class name. And now here I'm actually gonna cheat and look at how I implemented this thing before. And this is the helper, so I'm gonna get this guy here, and I'm gonna put here. Oops, Control V. Okay, so this is the list of student cache by student class name. And so if this thing works, we can do a recompile, and we can do the list of students by name, and we can pass here class A, and it works. But if you pass class B, it's not there. So if we start another class for class B now, and we do the class B now, it's there. Class A is here, and we can list all and show both. Awesome. Things are getting good. What else do I want to show you all? Okay, let's talk about like process failing and booting up once again. So right now our cache, if it fails, nothing is going to spawn it back again, right? We can be sure of that. Just look at the spawner here, and we are gonna be copying this guy here, and once again have the PID, but now I can do GenServer dot stop and pass like some reason foo. Cool. And now we can do say that assert process dot alive, and we pass the PID, and we can say that this thing equals to false, right? Okay, actually here process success, process is not restarted. This we can see, yep, it's success. So because the PID stopped and the process is not alive. But we want to that after this, remember this is a cache, so this needs to always be available for us. How we should implement this? So we need to supervise our cache, and for this I'm going to create a cache supervisor.ex module. Cool. And again, we're going to do helper supervisor because I'm lazy and I always copy the very first implementation from the documentation, which is this guy here. And now we can come here, and there we go. Magic, we have our supervisor, but instead of counter, this should be cache. And the cache is this guy here. And now we use supervisor, we can name as our cache, and there we go. And here this should be args. Here we can, it's fine for me to create a supervisor. That's unique actually. I don't care about the supervisor, or I don't care about the supervisor name. So we can create this guy here. Yep, we're gonna create like this. And this is gonna create a cache, 21 for 1. Cool. So now instead of like spawning cache, we're going to spawn a supervisor. So now if we come here and we go to our cache spawner, we are going to spawn the supervisor, which is this guy here and which is this guy here. Oops, actually that's our spawner. This is the supervisor, and now we don't care about the cache anymore. And still everything should be passing. So if I actually come here and run these guys here, actually, oh yeah, this one here, this should not be passing anymore, but this the one above should. So if I do this, and we're shutdown failed to, actually let me copy this guy here. So spawner, function call student start link supervisor. Okay, oh, I think I know what's the issue. At least I should know. So here, spawn child, cache supervisor, the cache supervisor, pass the args, and the oh, damn it. So here, this should be passing these args, and these args should come here. Cool. If I run the previous test, and oh yeah, okay. So now we can come back here to the spawner, and now here this is the supervisor bit. And we don't want to care about the supervisor bit, so we need to actually get our process speed, and for this we're gonna be asserting that, and we have the registry somewhere like this, vg underscore. Actually, I wanna get the one up below, so like this, this. Final here, and this should be class A. Okay, so if I do this for class A, this should return an element, and this element should have a PID, and now we have the PID once again. And if you run this test, ta-da, it works. Cool. Okay, now we have the process there. So actually, this test should fail. The process should be alive. I think that was so fast. So if I do a process.sleep for like, I don't know, 10 milliseconds, and we do this. Actually, no, it should be alive because, yeah, actually, sorry, this will work anyhow because the speed is no longer, the speed is not going to be the same as before. So, and here is the supervisor PID, right? Supervisor PID. So it's not how we want. So we get this PID here. And that's class A, that's a PID, and then we stop it, and the PID, and PID's alive, and then we do this, and everything should still be valid. But we should have another PID. So if I actually do this guy here, and this again, there should be a PID 2. If I run this, and now I need to probably wait a little because it takes some time for each process to be recreated. And there we go. So we notice that the process stopped, and the GenServer started another PID for us, and we can assert that the PID 1 differs from the PID 2. Okay. And now it really depends on the behavior. So let's say you want really that the process stops after, okay, so actually I think if I do this thing normal, this still pass because the restart mechanism is permanent. Okay, just to review another thing here. If we do have GenServer and we go and we search for permanent, yeah, we see that like by default the GenServer starts like the restart strategy as or property as permanent, but there is one called transient that pretty much if the GenServer stops like normal, it shouldn't be restarted. So like it really depends on how and what we want to test here. But just for the sake of example, since like that's the purpose of this tutorial, we say the GenServer restart is transient, and now our test should fail. So if I do this, then I should say like an empty string. Yep, it's an empty because the process exit normal, and when it exits normal, it does not restart the process. But if we put maybe here like abnormal, we should have everything working as expected. Yep, and there we go. Guys, so that's pretty much what I wanted to cover in this video. So we see that we have like the cache. Cache is like, it's really important for you to like create a struct out of your caches, create like a type T so that you can pretty much say that in your oh, we didn't actually do anything with students. Okay, sorry, let's continue the video, and I totally got misled here. So one thing that we can actually do so that it really behaves as a caching mechanism is we can put here a continue, and this here is gonna call another work for us called fetch users. And this, we need to implement the handle continue, which is pretty much a handle cast with another signature, continue. The name of them is called fetch users. Here we are going to probably need the underscore module, and we're gonna need the student class name. Student class name receives here the state, and here we probably need to assign the students to our state. So assign student state and students. Here we don't have students, so let's do here students receive an empty array for the moment, and we don't have this function up to now, so let's define one here, left p and students, and we have here the state and students, and let's use the syntax around struct to update the state. So state and students, and let's put here students. There we go. I was just mentioning for you that a good practice around GenServer is that we can probably now create a spec saying that this guy here receives we can actually alias our cache here. So we can do alias this, and now here we receive a cache.t and some list, and we return our cache.t. There we go. We know that this thing is a reducer. You could pretty much like and this here, all these functions, even though they are public, they should be private. Whoops. There we go. And actually, I'm gonna say that reducer is a specific entity. So reducers, and there we go. There we go. I'm gonna put this guy here. Oops. Okay. And now, okay. Normally, these fetch users should live in an external module, just for the sake of example, and we're gonna have like some sort of core module here that has a function called list students, and here we're gonna have some sort of criteria, which we use our student class name for that because that's how we use for this example. But remember that this could be pretty much like any query that you think might be interesting. For this, we're just gonna create here the core module. Here we're gonna have def list students here, and we're gonna have like here some criteria, and in here we should have like a list of students. I prepared actual list of students here. I'm gonna pretty much copy and use it because this will make us more efficient. Okay, so here there we go. We have like a bunch of students here for class A and class B. And pretty much we got filtering based on the student class name. So now we have this guy here. We can go back to our cache and now we can alias the core module, and there we go. And if we stop and start our servers once again, and we go to our spawner and we start our cache, and we come back here and paste and start, and now we grab our cache PID, and we get the state, and I didn't create a call example here. Example call, and do this dot get state, and just pass the PID, and here, so we do this, and now we pass the PID, which should be 0.6490, and this, we see that we have our cache up and running with this value here. And like if we want to be like really simulate the stop of our process, and we're gonna pass here again this bit here, and let's say here foo, we see that our process stopped. And if we get like it's a different PID, and if we check here with 654, we still have our cache running even the process died. Okay, now let's really review what I wanted to go over, which is pretty much the idea around always creating struct for your GenServers, setting up the type for it. Type specs is always interesting, so that this is going to be on call, this state, so you can pretty much say that this thing here, spec, is going to return. This is a PID, and I honestly have no idea what a PID is, so I'm going just to put here any, and this thing here is going to return cache.t, and what else? It needs find. This is just a bunch of callbacks. We know they have a reducer around this is something that receives a cache and returns a cache. And we have, this is the concept that Bruce Tate teaches in his course around like CRC. We have the handle continuous, so that starts the process. After that, we can maybe talk about restarts and other strategies in another video, because this is getting quite big up to now. And I hope you guys enjoyed. Like, we know how to create another caches on demand for a specific student class type. We can have a supervisor if the cache stops going to be respawned. We take a look on two of the restart strategies, which is the permanent and transient. And this is like the core module where we would theoretically like mock the idea of reaching out this external service, which would return us some data. We're going to do some filtering and stuff like that. And our registry helper, which allows us to register all the process running for our registry, so all the student cache process, and also a way that we can use this guard here, which is something really interesting and different from Erlang, which allows us to like pattern match and get all the student classes by student class name. And we also took a look at a bunch of the unit tests. So supervisor, I don't know if we added one, no, but we did it for spawner. So here we can see that like we can create a PID. We can see which is the PID when we can assert that that thing is also a cache. We can see that the process is not restarted if we actually think here the process is not. I think it is one. Yeah, this will work because we are changed to abnormal, but if change to normal, this will fail, if I'm not mistaken. Yep, it will fail. So I'll review that about like the transient property of a cache. And again, around caches, we can assert that the registry works by creating caches with the same name, and seeing that it's already started, and we can check that the process successful. Theoretically, there's one more function for us to test, which is the get state, that we should like create another describe block, but that's not that much necessary. Well, this is the first video of the PHX UI YouTube channel. Hope you enjoyed, and until next time, take care. Bye.